larger and larger. But when we work with time, specifically with clocks, the numbers cycle back on themselves. It will never be 49 o'clock. Once 12 o'clock is reached, we go back to 1 and repeat. If it's 11 a.m. and someone says, see you in 4 hours, you know that 11 a.m. plus 4 hours is 3 p.m., not 15 a.m. Math worked on the clock, where numbers restart after passing 12, is called clock arithmetic. Clock arithmetic hinges on the number 12. Each cycle of 12 hours returns to the original time. What do 2, 4, 26, and 38 have in common in relation to 12? Well, when divided by 12, they each have a remainder of 2. That's the key. A good visualization is to wrap a number line around the clock with 0 at the starting time. Each time 12 on the number line passes, the number line passes the starting spot on the clock. This is referred to as modulo 12 arithmetic. In general terms, let n be a positive integer. Then n modulo 12, written n mod 12, is a remainder when n is divided by 12. If that remainder is x, we would write n equals x mod 12. So note, 12 mod 12 is 0. There's no remainder. Find the value of the numbers modulo 12. So we literally just take 12 goes into 93. And what is that? 7 times, leaving me 84, having a remainder of 9. So 9 would be the remainder. That would be the answer. Okay, what about 387? Again, 387. Well, that's 3, 27, that's 2, and 3. So this would have a remainder of 3. That's what's unusual about this. The number we're looking for is the actual remainder. So if it is 9 now, what time will it be in 43 hours? Well, we just take 9 and we add 43 and we get 52. Then we take 12 into 52 is 4, which is 48, and we have a remainder of 4. So it would be 4 o'clock. If it's 7 now, what time will it be in 34 hours? So again, 7 plus 34 gives us 41. 12 into 41 is 3. 36 with a remainder of 5. 5 o'clock. Recall that clock arithmetic was referred to as modulo 12 arithmetic. Multiplying a modulo 12 also relies on a remainder when dividing by 12. Multiply modulo 12 is just to multiply the two numbers when dividing by 12. So what is the product of 4 and 19 modulo 12? 4 times 19 is 76. 12 goes into 76. 6 times 72. So the answer is 4. You agree to text your friend every 3 hours while driving across the country. You begin your trip at 8 a.m. What time will it be when you text your friend the 15th time? Now, the first time will be 3 hours, so the 15th time would be 45 hours. 8 plus 45, 53. 53, 12, 4, 48. So we know 5, but then we have to think, okay, so we go around 4 times. So the first time we go around, it's 8 p.m. Second time is 8 a.m. Third time is 8 p.m. Fourth time around is 8 a.m. And then 5 more, 5 p.m. So 2 full days and then 5 p.m. So clock arithmetic processes can be applied to days of the week. Every 7 days, day of the week repeats, much like 12 hours, the time on the clock repeats. Only difference will be that we work with remainders after dividing by 7. In technical terms, this is referred to as modulo 7. More generally, let n be a positive integer. Then n modulo 7, written n mod 7, is the remainder when divided by 7. This value is x. We write n equals x mod 7. So your family shares the cooking duties in your home. You've agreed to prepare a meal every 5 days. The last time you prepared dinner was Tuesday. What day of the week will it be after you've prepared the meals 20 times? So if we call Monday day 1, Tuesday is day 2. That's the first time we did it. So to do it 20 times, we're going to add 19 more. So that's going to give me 21. 7 goes into 21 3 times with a remainder of 0, which means we will be back to Tuesday. Or is it Monday? Let's think about this. 100 days will have passed. So that's not what we're looking at. Scratch that. Every 5 days, 5 times 20, 20 more times. So 5 times 20, 20 is 100. So that's the number we want to do. 7 into 100, or our remainder is 2. So 2 days beyond Tuesday, which will be Thursday. And that finishes up 3.7, clock arithmetic. Have to be careful with this. It can get kind of, it seems so simple that it's easy to get a little mixed up.